A very warm good morning to you all from Bridport. It's lovely to see so many people here. My name is Sam Knight. I'm a barrister specialising in public law. Spent much of the last decade being a thorn in the Home Office's side on its treatment of those in immigration detention. But I also live locally. I live with my family in my lurcher in the village of Shute in East Devon, surrounded by farmers of many different types, food producers, lots of deer, pheasants, cows, and some sheep. In fact, the sheep were in formation this morning. I think they knew who was arriving. So like a lot of people in this room, I've got a foot in an urban camp and I've got a foot in a rural camp. It's an absolute privilege and a pleasure to be introducing George Monbiot this morning. We've got a full house, and I understand we've got a full pavement outside as well. George won't need any introduction to you, but I will say a few words. With a degree in zoology, he started out at the BBC, making natural history and environmental programs. He moved to the World Service before embarking on his career as an investigative journalist. And as I'm sure a number of you have, I've been reading his columns in The Guardian for a very long time indeed. I've only ever been asked to leave one country in my working career. George has been declared persona non grata in 7. He's been sentenced to life imprisonment in absentia in Indonesia. He's been shot at, beaten up by military police, shipwrecked, and stung into a coma by hornets. Along the way, he's written about the people of West Papua, about expulsions of Brazilian peasant farmers from their land, and about loneliness, as well as the threat of corporate power to UK democracy. And I mention these in the context of an individual who is not frightened to speak out to power, which in these times we know is extremely important. But it's George's writing on climate change, on wilding, and on the ecocide taking place in our waterways and in our land as a Guardian columnist, and in his books on these subjects that I think he's become best known for in recent times. He's won numerous awards along the way, including the UN Global 500 Award for Outstanding Environmental Achievement, which was presented by Nelson Mandela, and most recently, the Orwell Prize for Journalism. And we're here to talk about Regenesis, which is an expose on the appalling state of the health of our land, our food, the damaging effects of high-density, high-chemical farming, and its impact on global warming. And I think at least half of the book will unite a lot of people, unite people who, whether they eat meat or don't eat meat, or whether they're urban or rural, farmers or non-farmers. But it's the second part of the book, which is, I think, much more controversial, and something we're going to talk about today. It's the solutions, what we do about food. But George, can we start off, and it's really wonderful to have you here today, can we start off by you just setting the scene for us about why farming you think is so bad for the environment and for us?
Thank you very much, Sam, and thanks everyone for coming. So, it's a really difficult subject to talk about because it is so visceral, it is so deeply emotional, and we have thousands of years of history which embed farming in the warp and weft of our lives, and so we don't go there. We don't challenge the farming industry in the same ways that we might challenge other industries like fossil fuels or plastics or chemicals, for example. And yet, the really shocking reality is that farming is the most damaging of all the things we've ever done to the planet. It's the number one cause of habitat destruction, the number one cause of wildlife loss, the number one cause of species extinction, the number one cause of land use, which I believe should be the most important of all environmental issues, but we don't talk about it as such, the number one cause of freshwater use, the number one cause of soil degradation, one of the greatest causes of climate breakdown, of water pollution, and of air pollution. And yet somehow we just don't want to go there. And there are some forms of farming which are much more damaging than others. And livestock farming is way out there, massively more damaging per kilo of production than any form of plant growing at all. The fundamental issue is there is no good way of doing it at scale. Intensive livestock farming inevitably destroys rivers. Extensive livestock farming inevitably destroys land. I'll explain this very briefly, or I'll try to. The great majority of the animal products that we come from factory farming. We don't like to think of this. In fact, we are in deep denial about it. In the UK, it's 84% of all the products we eat from animals are reared in factories. And if we treated our cats and dogs like we treat those farm animals, we would be sent to prison for several years. It's this weird dissonance, this sort of, we hold two completely separate ideas in our minds. We're animal lovers and we're meat eaters, and you just can't be both. It just doesn't work, and yet somehow we try to make it work for ourselves. All those animals which are in factories, in other words, giant barns, pushed together in very large numbers, require grain for their feed. And this grain is generally grown thousands of miles away, for instance, in the Cerrado region of Brazil or in the US Midwest, shipped around the world, and it contains a great deal of nutrients, of course. That's why they're eating it. So the animals absorb some of the value of that food, but they also excrete a lot of those nutrients. And wherever you've got a very high concentration of animals, which means, in other words, factory farming, you have a massive nutrient flow coming out of those animals, and those nutrients have to go somewhere. And the trouble is that this is a high-volume, low-value product, animal dung. And so you want to get rid of it locally. So farmers spread it on their fields, and they say they're fertilizing the fields, but there's far too much of it being produced for the soil and the plants to absorb. And so a very high proportion of it, inevitably, I mean, this is just a mathematical function, a very high proportion of it washes off the land and into the nearest river, into the stream, into the river, eventually into the sea, and it kills everything along the way. And wherever you have a concentration of intensive livestock farming, you have riverside, the death of local rivers. And that's happening worldwide now. No river can withstand intensive livestock farming, and that's just a mathematical function. Even when the farmers are ticking all the boxes, meeting all the rules, there's just too much nitrogen and phosphorus for the soil to absorb. That causes eutrophication, an excess of nutrients in the rivers. That causes algal blooms. They photosynthesize by day, they respire at night, and in respiring at night, they draw the oxygen out of the water column and kill most of the life in the river. They also make the water too murky for macrophytes, large plants, multicellular plants, to survive. And in many rivers, it's the macrophytes like ranunculus, water crowfoot, which anchor the entire ecosystem. They're like mangroves around tropical seas. It's where the fish breed, the insects breed, everything hides. You lose that, and the ecosystem collapses. So people say, well, we don't like intensive livestock production, so let's go for extensive livestock production instead. Let's have our free-range, pasture-fed meat, and our free-range chickens, and our free-range dairy cows. And it's undoubtedly better for animal welfare. There's no question about that. And if the stocking densities are low enough, it's going to be better for the rivers as well. The problem is, by definition, and again, it's a mathematical function, because what extensive production means is using more land for a given amount of produce. So by definition, you're using more of that most important of all environmental resources, which is land. And this is important because every hectare of land we use for our own production or our own extraction is a hectare which cannot support wild ecosystems. And the great majority of the world's species depend for their survival on wild ecosystems. And indeed, Earth systems themselves depend for their survival on wild ecosystems. Now, we can look at what we're doing to the world's wild ecosystems and where the problems are coming from. In other words, we can look at the issue of land. And on the rare occasions when environmentalists look at the issue of land, they look at urban sprawl. And urban sprawl is a blight. It's bad for cities and it's bad for the countryside. But the entire urban area of the planet, all the homes, all the businesses, all the infrastructure, occupies 1% of the planet's land surface. Farming occupies 38% of the planet's land surface. Of that, 12% of the surface is crop growing, right? And almost half of those crops are grown to feed animals in intensive livestock farming. 26% of the land surface is for grazing. This is by far and away the biggest human use of land. And all the rest of the land on the planet, incidentally, is either forests, protected areas, deserts, ice caps, or mountains. So places where you can't farm. So any expansion of farming goes into protected areas and forests, which unfortunately is happening at great speed. It's being driven above all by livestock farming. But even in places where the transition happened many, many years ago, that farming imposes a massive ecological opportunity cost and a massive carbon opportunity cost. The ecological opportunity cost means what would be there if you were not grazing that land. Now, there's been a phenomenal amount of BS surrounding the pasture-fed meat, and it's in harmony with nature, it's sequestering carbon, it's doing all these wonderful things. And unfortunately, this is on a par with climate science denial promoted by the fossil fuel industry. This has been promoted by the livestock industry, but in this case, by contrast to the fossil fuel climate denial, it's been taken up a lot by ordinary citizens because we love the bucolic, romantic image of cows grazing in the fields, of sheep grazing on the hills. And so we find ourselves inadvertently repeating industry talking points about how this is mimicking nature, how it's sequestering carbon, how it's creating habitat, and it just is not true. You can have systems like, for instance, Knepp in Sussex, where you have a very, very tiny number of livestock, creating what ecologists call an intermediate disturbance regime, which can be very good for wildlife. But you're talking about really tiny numbers of livestock, and it must not be confused with a production system. If that were the only way in which we produced our meat, and it's the only ecologically friendly way of keeping domestic animals, then only millionaires would eat it. It would be an extremely rare, ultra-luxury product, and it would cost an absolute bomb. But we use examples like that to say, well, livestock farming as a whole is good, because look, Knepp is doing good things, so therefore having cattle outside is going to be a good thing. But you raise the stocking density above that very, very low level, 54 kilograms per hectare is what they produce there. You raise it above that tiny level, and instantly you tip the system into one which has no trees, because livestock browse out seedlings, tree seedlings, as they're so nutritious. One which there are no wild herbivores because they're fenced out or they're outcompeted. There's no large predators. There's no large predators in Britain at all. But when we try to bring back the lynx or bring back the wolf, it's the livestock farmers who say no, we can't have this. In fact, they've even resisted golden eagle and white-tailed eagle reintroductions. And in other parts of the world where large predators still exist, it's the livestock industry driving their destruction. Large predators are absolutely essential for ecosystems. And every single guild, functional group of animals is reduced in a situation where there are livestock, except for detritivores, those that eat dung, in other words. But all the other ones, you have lower numbers. And the reality is that in every situation where you remove the wildlife, remove the livestock, you see an enhancement of the wildlife, unless you take the livestock down to a very, very low level. And so, but there's been a huge amount of misinformation, unfortunately, in the public domain. So you've got this very river-hungry system on one side and this very land-hungry system on the other side. And it's become very clear to me, having resisted this for a long time, that just as planetary survival depends on leaving fossil fuels in the ground, it also depends on stopping animal farming.
So can I come back to something that you mentioned first of all, which is these factory farms that we just wouldn't recognise. You won't see a blade of grass, you won't even see an animal outside. It seems to me that a lot of what's wrong with our society and the way we produce food is about vast corporations. It's about chemical companies which have been able to lobby governments all over the world and get people hooked on fertilizers. And of course, we now know the prices of these are going up, leading to price price hikes in food as well. There's been a lot of talk about the need for greater regulation and greater control, breaking down monopolies. I mean, what do you say about that? You've obviously written about it in your Captive State book. Should we legislate, regulate a lot more to break up these mega farms, break up these enormous corporations, and stop people being allowed to put chemicals on the soil, stop these companies producing these chemicals?
So there's several issues here, and they're all important ones. In researching Regenesis, I read over 5,000 scientific papers, and a lot of them were terrifying, but the most frightening of all was a series of papers saying the global food system is looking very much like the global financial system in the approach to 2008. And what was so frightening about these papers is that no one paid them any attention. There was no take-up by the media, no take-up by government, by policymakers, and yet you read them and you think, okay, this looks not just frightening, but inevitable unless we pull out of this spiral. And what they were doing was examining the food system from a systems theory approach. And almost all the things that are important to us in life are complex systems: human brain, the human body, human society, ecosystems, the oceans, the atmosphere, the global financial system, the global food system. They're all complex systems which have dynamics that are counterintuitive. Very seldom are people taught about complex systems unless you take a very particular degree. Luckily, my degree included ecology, and ecology pioneered a lot of systems theory. And we're taught about the world with circuit diagrams, as if it's like an electrical circuit. We talk about ecosystems that way, we talk about politics, we talk about economics that way. It's all like circuit diagrams. It's completely wrong. It's like being taught Finnish and being told it's English. It's a totally different approach, and complex systems are formed as a result of billions of random interactions or randomly distributed interactions, which in bizarre and counterintuitive ways create spontaneously self-organized systems. And these self-organized systems are self-regulating within a certain range of stress, but you degrade them beyond a certain point when they lose their resilience and they suddenly collapse. They don't respond to stress in linear and gradual ways. They absorb it, and then suddenly poof, their self-regulating properties become self-amplifying properties, and shocks get multiplied across the network as they're transmitted. And after the global financial crisis, the Queen went to the Bank of England and she asked the sage heads there, why did no one see this coming? And all these wise old people looking at their shoes say, oh, don't know, ma'am. Oh, the dog ate my homework, ma'am. And it was a very good question she asked. But one of them, Andy Haldane, the chief economist, he did something quite brilliant. He said, I don't know, but I'm going to go away and find out. And the person he went to was my old ecology tutor at Oxford, Professor Lord Robert May, who was one of the inventors of systems theory. And he said, what can ecological theory tell us about why the financial system nearly collapsed? And they produced this brilliant paper together, and then Haldane made this great speech to the Bank of England explaining systems theory to people who'd never been exposed to it before. And it was the first explanation of how a relatively small shock, the US subprime mortgage crisis, almost brought down this totally massive global system. There'd been far bigger shocks before, but it hadn't brought down the system. Why this one? And they showed how the system had lost its resilience. It had lost the four key elements of resilience, which are its redundancy, spare capacity in the system, its modularity, the degree to which it's compartmentalized, its circuit breakers, and its backup systems. And all of those have been stripped out by corporations pursuing their own efficiencies within that system. And it made perfect rational sense for each corporation to be doing what it was doing, but you put it all together and the system collapses. And exactly the same thing has been going on in the global food system. So 4 corporations now control 90% of global grain trade. They've become too big to fail. This is a phenomenally dangerous situation. Countries have polarized into super importers and super exporters of food. And in all the major food commodities, it's just 4 or 5 main exporters now of producing most of the food bought elsewhere in the world. 60% of the calories farmers grow come from just 4 crops: maize, rice, wheat, and soy. And a huge proportion of that food is channeled through a small number of pinch points: Turkish Straits, Suez Canal, Panama Canal, Bab el-Mandab, Straits of Hormuz, Straits of Malacca. You only need a couple of those to go down and bang, the food chain snaps. In fact, if Russia's invasion of Ukraine this year had coincided with that container ship being stuck across the Suez Canal last year, hundreds of millions of people would just have seen their shelves clear almost overnight. We've become extremely dependent on this highly concentrated corporate model. Some of that is kind of inevitable. You can't, because we live in big cities, we can't grow all the food we need locally because there's too many of us, so we do need to import it from places a long way away. But some of the ways in which it's been structured are there entirely for the benefit of the corporations, not for the benefit of the people. And similarly, with what the other part of your question, which is the sort of development of what I call the global standard farm to produce the global standard diet. And this is farms which have got bigger and bigger through land grabbing and consolidation, are using exactly the same chemicals, exactly the same machinery, exactly the same seed, all supplied by exactly the same corporations, and there's very similar concentrations in the production of seed, chemicals and machinery, and indeed breeding stock for livestock farms as well, all extremely concentrated, and all undermine systemic resilience. So one of the many ways in which that happens is that there's been a great stripping out of genetic diversity in crops. We've lost 75% of that since 1900. And so if a crop disease takes off, it can spread very fast. And we've seen this with the UG99 wheat stem fungus, which has now spread across Africa and into much of Asia. And because it's moving through genetically identical crops, there's very little that can be done to stop it. So this is an extremely dangerous situation, and governments have not got involved. I mean, you talk of regulation, there is none. At the global level, there is just none. It's just been left to the invisible hand of the market, and this sort of almost religious belief in this invisible hand that godlike it's going to sort everything out is completely destroyed the moment you understand systems theory. Because what is in the individual interest of the business person or the corporation undermines the system as a whole. By pursuing your own efficiencies, you destroy the resilience of the system.
Right, and so, I mean, one of your ideas that you develop in the book is the microbial food industry, and of course there are people in Finland, Solar Foods, which are already producing that. But that industry in itself is prone to exactly these problems, right, unless it's regulated, because you will get these mega companies presumably distributing.
So this is the logic of capitalism. It tends towards concentration and it tends towards monoculture. And I wouldn't start from here. But here's where we are. And so we have to try to tame this system. And I mean, eventually, I'd like to see a completely different system, but that seems to be some way off at the moment. But in the meantime, the approach is not to say, because the global grain trade has become highly concentrated, let's abandon the global grain trade. Because if we were to do that, billions would instantly starve. And the same applies to novel foods. You could say, right, there is a real danger, exactly this, of the same processes happening in new food production as is happening in existing food production. I mean, we're not inventing any new pressure, but we don't want to replicate the dysfunction of the current system as we develop new food systems. Now, for environmental reasons, and indeed for humanitarian reasons, we desperately need to develop new food systems. I haven't mentioned the humanitarian reasons yet, but partly because of this loss of systemic resilience, we are seeing a reversal of some of the extraordinary gains in feeding the world that have been made since the 1960s. In fact, there was, one of the most remarkable and unexpected aspects of recent world history is that fewer people have been hungrier when we expected far more people to be hungrier. And that's the result of a sort of necessary but fundamentally unsustainable shift, which was towards the Green Revolution. And that led to a massively increased yields, cheaper food, and as a result of that, because cheaper food is more accessible food, more people being fed. And so we saw a steady decline in chronic global hunger from the 1960s until 2014. And at the time, there was a lot of, everyone just assumed this trend was going to continue. And there was a lot of very optimistic talk of eliminating global hunger by 2030, meeting the first Sustainable Development Goal by 2030. And this was wonderful. But then in 2015, the trend began to turn. And global chronic hunger has been rising ever since. And the really weird thing about this was that between 2014, when the trend was still downwards, and 2015, when it turned, the price of food fell substantially. Global food index went from 115 to 94, and it stayed below 100 until mid-2020, and yet global hunger continued to rise through that time. And what was happening there, we were seeing the loss of resilience in the global food system, because even though global prices were low, shocks were being amplified across that system. So you'd have a small speculative surge in one commodity, you'd have some export restrictions from one country, you'd have a bad harvest in one place, and instead of that being damped down by the system, as a healthy, resilient, complex system does, those shocks were being amplified, and they were landing not on the world as a whole, but on the poorest nations at the end of the queue, using soft currencies to buy into a hard currency market. And so we were seeing local prices spike even as global prices were remaining low because of interruptions in supply. And that's just been getting worse and worse. So this is also a major humanitarian issue. And it's being greatly exacerbated by environmental collapse, because as a result of the loss of irrigation water, the loss of soil moisture, some places already becoming too hot to work outdoors, environmental disasters, everything from wildfires to hurricanes and flooding, of course, and heat waves. A whole lot of environmental impacts are now hitting food production in some of the world's key grain baskets, and that's only going to get worse. And many of the world's countries simply do not have enough fertile land and enough water to support their population. So what are we going to do? Well, this is where this extraordinary new technology comes in. And of course, many people balk at it. We are all neophobic. We don't like new stuff, particularly when it comes to food. And so, the sort of reflexive response is to say, oh, no, we can't go there, which is basically to eat microbes. And what we've seen is, in the last few years, is the commercial development of a technology that goes back to the 1960s, developed by NASA for its space program, though it's not actually rocket science. It's quite simple. It's a refined form of brewing, which is multiplying microbes that produce a high-protein flour. And the extraordinary thing about some of these microbes is they require no agricultural feedstocks at all. So there are some which subsist on hydrogen and others which can subsist on methanol, both of which can be made through green electricity and don't require the use of land. So, well, except the land for generating the electricity, which is far, far smaller amount. And I went to Helsinki to a company called Solar Foods, which was producing this, and I was the first person outside the lab in the world to eat a pancake made from microbial flour. Small flip for man. And the extraordinary thing about this pancake was it tasted exactly like a pancake, but it was produced with a tiny fraction of the land, a tiny fraction of the water, a tiny fraction of the fertilizer that farming uses, and it was a closed system, so you don't get any leakage of fertilizer, pollution, all the rest of it out into the system. They were producing this sort of golden-coloured flour because the bacteria got beta-carotene in, which is about 65% protein. And this potentially becomes the basis of far better substitutes for animal products than you get from plant proteins, which are tied up with a whole lot of complex secondary plant compounds and difficult flavors which are hard to disguise, which is why a lot of these substitutes are such poor quality, and they have very long ingredient lists, and they need a lot of processing. This makes it all much simpler, much healthier, and ultimately much, much cheaper. But also, they have the potential to trigger a whole new cuisine that we can't even imagine at the moment, any more than the first people to domesticate a wild cow were thinking of camembert. This is a potential dietary revolution as profound as the agricultural revolution was in the Neolithic, which invented bread and cheese and stuff like that. And we don't know where it's going to take us, but we've got this potential for minimizing to a tiny point the environmental footprint of food production, while maximizing the production of food and meeting this otherwise impossible to meet demand for high-protein foods for a population of 8 billion or 10 billion people. And they also have tremendous potential impacts on food sovereignty and food security. Because while most of the world's hungry countries might not have sufficient fertile land or sufficient water to grow their own food through agriculture, they are rich in something else, which is sunlight. And if you've got a food chain based on hydrogen or methanol, sunlight is your feedstock. And so, my ideal, my dream here, and this is where the politics comes in, is for a distributed microbial food system where every town can have its microbrewery, producing its own high-protein foods tailored to local markets. But for that to happen, intellectual property rights have to be weak and antitrust laws have to be strong. And in fact, that should be the case with every single sector in commerce right across the world. There shouldn't be Amazons, there shouldn't be Googles, there shouldn't be these giant companies which sweep up everything and monopolize those sectors. But we've allowed this to slip. We once had strong antitrust laws. We once had weak intellectual property rights. And lawyers recognized, didn't they, that those were necessary to create a fair world. Well, we need to get back to that situation. We need, and that is a political fight more than anything else.
Yeah.
So whatever the food system we have, that food system should be distributed and ideally predominantly in the hands of small and medium enterprises rather than big business.
So this is a good moment, I think, for us to come back to talk a bit more about the regenerative farming, because we've got a lot of people in the audience who may not like the idea of these pancakes. Maybe beer, okay, a bit of yeast for the sourdough. But there is, and I can speak, on behalf of a number of people here, there are a lot of people who are working in a very scientific way on things like regenerative farming, and not just on a small scale. The person you talk about in your book, Tolly, his farm is relatively small, but there are really good examples in this country now, places like Yeo Valley, places like Trewithen, which are, selling their food to supermarkets, doing it in a regenerative way. There's Wakelin's farm in Suffolk, which is an arable farm working on the commercialization of lentils and pulses and intercropping them in a sort of agroforestry sort of way. And a lot of people, I think, would feel very concerned about losing that. It's part of, they would think, I think, our human nature. We farmed for 12,000 years as a sort of as a species. So, I mean, what do you say in answer to that?
So what I'm talking about here with the precision fermentation is replacing high protein and high fat crops, which are foods which are primarily delivered through livestock, and as we've seen, there are big problems with that, but also through crops such as oil palm, coconut and soy, which all have their own problems. Now, it's much better to eat these things directly. If you're eating soy, if you're a Guardian reading, tofu eating wokarati, and I strongly recommend that you should be, then that's a far better way of consuming it than the great majority of the world's soy is used, which is passed through chickens and pigs before it reaches us. But even that, you can massively reduce the impact of high-protein food production if you switch from soy to precision fermentation. Thomas Linder, a Swedish statistician, estimates that you would reduce the land area needed by 1,700-fold if you switch from the most efficient way of producing protein at the moment, which is US soy farming, to precision fermentation. You'd use 1/1700th of the land. If you switch from beef farming to precision fermentation, it's 168,000th of 168,000th of the land is what you're talking about. I mean, a tiny, tiny fraction of land use. And that then enables us to do the thing on which I believe our survival hangs. In fact, I don't think we're going to get through this century unless we do it, which is to rewild a very large portion of the world's land. And in doing so, we restore wild ecosystems, we stop the sixth great extinction in its tracks, and we draw down vast amounts of carbon dioxide from the atmosphere. And if we don't do that, it's very, very hard to see how Earth systems are not going to collapse and we go with them. It's very hard to see how we're not going to be swept off the planet in a sixth great extinction. So there are conflicts here because we can't have everything. We can't have this sprawling, extensive agriculture, this agricultural sprawl occupying vast amounts of the planet, and thriving, healthy living systems and sustaining our place on Earth for many generations to come, as we would hope to have. We have to make choices, and these are not easy choices. The choices have been muddled, they've been blurred, they've been deliberately obscured, there's a huge amount of denial involved. I understand all that. These are very visceral issues, literally and metaphorically. But these are still choices that have to be made. Now, there are some wonderful, genuinely regenerative plant-based farms. There's an awful lot of places which call themselves regenerative, which are nothing of the sort. And regenerative has become like sustainable. It's an adjective you just stick in front of whatever you were doing already. So you get regenerative ranching, formerly known as ranching.
Regenerative lawyering.
I dare say.
But as I see it, you don't see any place for these farms, these regenerative farms.
No.
Right?
I don't see any place for livestock farming.
Right.
There's loads of places for regenerative arable and regenerative horticultural, and in fact, it's essential that we switch towards those. We still need to produce grain. We still need to produce vegetables and fruit. In fact, we should be eating more vegetables and fruit than we're producing at the moment. But if you produce them wrong, you can do a fantastic amount of damage, and you can undermine future production by destroying the soil, primarily, which we get 99% of our calories from the soil. Most people have no conception even that it's an ecosystem, let alone a biological structure like a coral reef, and we treat it like dirt. And in doing so, because soil is a complex system, we are pushing it towards its tipping point whereupon it collapses, and that collapse is called a dust bowl. And what happens when you systematically degrade soil across a long period, you don't notice very much change, and then suddenly you'll get a major drought will hit it, and the erosion rate can rise 6,000-fold overnight. And that what you're seeing there is systemic collapse, and then it just blows straight off the land because it's lost its structural resilience. So it's absolutely essential. We have genuinely regenerative farming, but regenerative farming is not the same as agricultural sprawl. And a lot of very sprawling, low-yield farming is called regenerative, and I don't see it as that at all. I see that as exactly the opposite. That is inflicting a massive ecological and carbon opportunity cost by occupying so much land for so little yield. Low-yielding farming is not sustainable because it takes up too much of the planet's surface. The holy grail is high yield and low impact, and very few people have been able to achieve it. It's not easy, and one of the reasons we haven't is because of the very poor state of our understanding of soil. Now, Ian Tolhurst, who's a guy I follow closely in the book, has done it. He's a grower based in South Oxfordshire who for 34 years has been raising his fertility and raising his yields without using any fertilizer or any manure. And he's done so by tweaking the relationship between plants and bacteria and fungi in the soil. He's a great natural scientist. He's been experimenting for years and years and years, and he's hit that sweet spot where on grade 3B land, he's hit the lower bound of what conventional growers are getting on better land. It's extraordinary, with no fertilizer, no manure. Some people have been able to replicate that, and some people haven't. We don't know why yet. We don't know why it works in some places and not in others. It's something to do with the soil, but we don't know what that something is. We need masses of R&D into soil science. It's been hugely neglected. I mean, it wasn't until 2020 that a paper was published saying, we think we might know what soil is now. I mean, literally. And it is this magical I mean, its properties are off the scale. It's just, when you begin to grasp what's going on, you can hardly believe what's going on. This paper, incidentally, was called Soil as a Composite Extended Phenotype of the Microbial Metagenome. And what it proposes is you get a general genetic response in the soil to changes in carbon levels. So the genomic length as a whole, right across the combined microbial genome, shrinks when there's less carbon and rises when there's more carbon. How is this being coordinated? It's almost like the soil itself is a living organism. And at the same time, as DNA length is shrinking, RNA operons are rising, which suggests an enhanced metabolic response, which suggests that if conditions change, the whole system can change to meet those new conditions. What the heck is going on? Nobody knows. We just don't understand this. It's incredible. I mean, it's like it's extraterrestrial, madly amazing, and yet it is as terrestrial as you get. I mean, it is literally terrestrial. And here we are spending billions on the Mars rover program, and we don't even know what's going on the surface of our own planet.
Yeah. We're going to open up to questions from the audience, but before we do, one last question from me. I mean, just coming on back to this subject of soil, I think Reading University was the last place to have a pure soil science degree, which has
undergraduate degree.
Ended.
Yep.
And that in itself is astonishing. It ended, I think, 5 or 6 years ago.
Yeah.
There's somebody who lives locally who was one of the last students studying it as a pure
It's utter
subject.
madness, isn't it?
It
Utter
is
madness. And just at the time when we suddenly start getting really interested in the soil. But it's like, oh, yeah.
But I just wanted to ask you about these livestock farms, because these mixed, sort of relatively small livestock farms, which will mix arable, which will crop rotate, who care about their soil and who are using scientific methods and would say that they are aiming at a carbon neutral system. Would you see that is a potential as part of the solution, not the sole solution, but part of a solution?
I'm sorry to say that I don't. No.
Okay.
And this isn't because I doubt. It isn't because I doubt the sincerity of the people attempting this. There's some very wonderful and sincere people who are absolutely doing their best, but unfortunately the facts are against it. And so, for example, there's this myth going around that because the methane that ruminant animals produce ultimately derives from carbon dioxide from the atmosphere, there's no net warming impact of that. But it's just, actually, the roots of that were exposed just last week. They came from the Clear Center, University of California, Davis, which turns out to have been founded and funded by the livestock industry. And it's just pure climate denial. Methane is an incredibly powerful greenhouse gas. The biggest source of methane on Earth is ruminant livestock, in other words, cows, sheep, and the rest, animals with sort of 4 compartments to their stomach. They also produce a lot of nitrous oxide. These are far more powerful greenhouse gases than carbon dioxide. Bringing them down is the #1 priority because you get a much faster radiative forcing response by reducing the amount of methane in the atmosphere than you do by reducing the amount of carbon dioxide in the atmosphere. So even these supposedly cyclical farms are actually having a very high greenhouse gas impact. But worse than this is that manure is a very poor crop or soil amendment. One paper suggests that you lose 37% more nitrogen from manure than you do from artificial fertilizer. Now, artificial fertilizer is bad enough and causing enormous problems for us. But the whole promise of organic, rotational, regenerative, mixed farming was that it was going to close the nutrient loop, right? It's doing exactly the opposite. It's opening that nutrient loop out and leaching nutrients at an even greater rate than conventional farming. And the reason for that is that while artificial fertilizers cycle too fast, organic fertilizer, manure, cycles too slow. And so you have to apply the manure before you sow your seed. And so it already starts losing nitrogen before there's any plants to absorb it. Then it supplies some of the nitrogen, but very often not as much as they need, to plants during their growth phase. And then it keeps on releasing nitrogen even after the crops have been harvested. And so that explains its leakiness. And of course, it loses some of that in solution, and that then goes into the rivers and causes eutrophication. It also loses some of that in its gaseous phase, nitrous oxide, which is a very powerful greenhouse gas. So it looks lovely. It looks like the systems we want to see, but we have to attend to the numbers. And what this whole argument comes down to is pictures versus data. I present the numbers and somebody says, but look at this picture of these cows grazing in a field. Isn't this lovely? Well, I'm sorry, we have to follow the science on this. We have to become food numerate. We've very painfully become energy numerate, some of us in the environment movement. There was that campaign, Do the Math campaign, started by Bill McKibben, where we had to work out, right, how much carbon can we afford to burn? How much do we have to leave in the ground? We got there. As a movement, we are energy numerate now, I would say. We are absolutely not food numerate. We trade in poetry, we trade in pictures. And I love poetry and I love pictures, but I think they're the greatest threat to life on Earth.
We're at a literary festival, come on. We haven't talked about food prices, we haven't talked about energy, but let's go to the audience and ask them some questions. Yes, over there in the back.
Thank you. I was going to ask about... oh, sorry, is that really loud? Okay.
No, it's good.
I was going to ask about energy. So I thought it was interesting. It's clear that these kind of microbial forms of producing protein use less land, but they presumably use more electricity. So where does that electricity come from? Does that not then have to sit on land and use the land in a different way?
Thank you. No, a very good question. And so the estimates, which I give in the book, include electricity production. Even then, you're using much, much less land. So the most land-hungry form of electricity production is solar power. You're still using a tiny fraction of the land that you would be with agriculture. If you use wind turbines, then you're using even less land because they have a smaller land footprint, especially if they're offshore wind turbines. It's a seabed footprint, but you get bigger turbines. If you were to go down the route, for example, of high-temperature gas-cooled fourth-generation nuclear plants, you're using, you could do it in a space the size of this theatre. You could be supplying much of the electricity required for, several counties' worth of food. And because in that case, you don't need to use electrolysis to split water into hydrogen. You can do it directly. You can directly crack water. So I think you have to reach 1450 Celsius in order to reach that point. So we're still talking about much, much smaller footprints. Now, the estimates I come up with in the book is that we would need to raise global electricity supply by 11% if we were to switch our entire protein production to microbial fermentation. Right? We'd need an 11% rise, but that's all things being equal. If we are already, which I really hope we are doing, and we should be doing, switching towards a low-carbon or zero-carbon electricity system, that system's going to have a great deal of surplus at some times of the day and some times of the year, because there's going to be times when it really strains to supply to meet everyone's demand, but there are going to be other times when, during the middle of the day, when there's loads of sunshine, for instance, where it massively exceeds demand, or during the middle of the night when there's loads of wind, it massively exceeds demand. We're going to have to oversize the system in order to meet demands, to meet the situation when supply is low and demand is high. And because the system has to be oversized, it's going to have surplus periods. And using those surplus periods to produce hydrogen or further down the line methanol, that means that the total expansion of electricity demand would be far less than 11% because you'd be using surplus from the existing system.
Great. Other question? Yes, down there.
Well, you haven't mentioned one source of protein, of course, which is fish from the sea.
Thank you. Yeah.
I would like to hear your views on getting more protein from that route.
Thank you very much.
The other point I'd also like to make, the microbiological protein that you're talking about, what is the amino acid balance of it?
Thank you.
You didn't say that. I know soy is deficient, but it can be balanced easily. I'd like to know your views on those.
Two excellent questions. Thanks very much. So, industrial fishing is the biggest threat to marine ecosystems on Earth. I mean, there's plenty of threats. There's ocean acidification, also there's pollution, etc. But industrial fishing is the number one threat. We're seeing ocean food chains collapsing at terrifying speed. We can't get any more out of that system. We should be getting a lot less out of that system. I mean, I would like to see the end of commercial fishing. I would like to see the great majority of the world's seas off limits for fishing, and if that were the case, we would scarcely believe the abundance in them. There's a wonderful book by Professor Callum Roberts called An Unnatural History of the Sea. I very strongly recommend it. And it shows us what there used to be around Britain's coasts. And you had Oliver Goldsmith describing the arrival of the herring. He said the main body of the herring came in shoals 4 to 5 miles wide. They rolled up the water ahead of them. Behind them, you could see, because the North Sea was then clear, because it hadn't all been, the bottom hadn't been dredged to pieces by trawlers, you could see the cod coming in. Not cod like we know today, cod 6 feet long. And alongside them, the small sharks, the spur dogs, the tope, the smooth hounds, and then the large sharks, including makos, threshers, poor beagles, blue sharks. Behind them, the dolphins and the porpoises, and behind them, within sight of the shore, the pods of sperm whales and fin whales come in to feed on the herring and their predators. And we've lost so much, and yet our baselines, the phrase shifting baseline syndrome was coined by a fisheries biologist, Daniel Pauly, to describe the way in which we forget what the state of nature was. So we conceive as normal and natural the state in our own childhood, and then we perceive a degradation from that state, and so we've got to get back to how things were in our childhood. But in our childhood, it was already severely degraded. I don't see fishing as a way out of this. I mean, there's some products, like mussels, for instance, where the impacts are very low. If you're farming mussels, you're pretty well talking about sort of plant production levels of impact, much, much lower impacts than other things. So I think that would be a reasonable part of the diet. But of course, can you scale it to feed huge numbers of people? Well, no, there's not going to be enough shallow, warm coastal waters to do that. On the second part, what was the second part?
Amino acids.
Amino acids. Thank you very much. Yes, that's right. The second part of the question. Yeah. The Cupriavides necator, the bacterium being produced by Solar Foods in Helsinki, it's the amino acid profile is roughly halfway between animal and plant amino acids. It's got all 9 of the essential amino acids. The great thing about microbes is they're really, really easy to tweak. And so, if you want to produce carnosine or creatine, bang, you can do it very simply. Omega-3s, you've got omega-3s. And so you can do everything with the sort of minimum intervention and the minimum of damage and produce these balanced high protein and high fat foods. That's another great potential advantage. Oh, sorry, one thing to say is they are high in nucleic acids. So one thing you have to do is to reduce the nucleic acid in processing the flour, because otherwise you get gout or kidney stones from that. But that's similar to all, every kind of flour we eat, something is being taken away from that. And so that's one aspect of the processing which has to be done.
Got time for one last question, looking at this side of the audience. Yes.
Apologies, I haven't finished your book yet.
Oh,
I know, but
many apologies are due for that. I'm outraged.
I'm sure you are. Who's listening to you, George? Are politicians listening to you? DEFRA, NFU? And if they were listening to you, how would we transition from what we have now to what you say we really should be doing? Is it like the end of the slave trade, when we have to throw billions and billions at farmers?
Thank you. There's a really excellent question. Yeah. As all these questions have been, thank you very much. So, on the first part of the question, is DEFRA listening? so DEFRA, right, is the craggy island of British politics. It's a punishment posting. And they've put Father Jack in charge at the moment. DEFRA stands for Doing Everything Farmers' Representatives Ask. And it's based in 17 Smith Square in Westminster. The National Farmers Union is based in 18 Smith Square in Westminster, literally. They might as well take the wall down between them. They're more or less one and the same organisation. And the NFU, I meet so many farmers who might not like me, but they like the NFU even less. And there's this constant theme I hear from farmers: we are not being represented by them. Because every environmental improvement is resisted by the NFU. Now, I know loads of farmers who desperately want to see environmental improvements. They want to see a better regulatory environment, because if there's not one, there's a race to the bottom, and they have to be as bad as the worst farmer. But they want to be better. They want to be able to do better and to make a living while doing better. But if someone's undercutting them by cutting environmental corners, they can't do that. And yet the NFU, rather than encouraging that enhancement of environmental standards, resists everything. It's trying to bring back neonicotinoid pesticides. It supports a badger cull, however irrational it might be. It's succeeded in getting back to autumn slurry spreading. I mean, every bad activity. I mean, it's been tearing down regulations left, right, and centre. It's just madness. So I think those will be among the last people we'll persuade. But change never comes from the centre. It always comes from the margins. The people who are protesting out in Buckydoos Square, they're the change makers. Not the people they're appealing to in Egypt at the moment. Governments there have no intention of changing anything. They're just going to nod and smile and talk and carry on until Earth systems collapse, because they would rather see the end of the habitable planet than upset their sponsors. So it's, we have to generate the movement for change, just as slaves and anti-slavery campaigners generated the movement which brought the slave trade to an end. It wasn't going to come from the slave owners, and it wasn't going to come from the governments. And we've done this many times before in history. And what we've done is we've reached social tipping points, because society is itself a complex system. And society does not respond to change in linear and gradual ways. It absorbs it, and then it suddenly flips, collapses into a different equilibrium state. But it can be a much better equilibrium state that it collapses into. And it can happen with tremendous speed. And we now have a body of scientific research, both observational and experimental, which shows us more or less where that tipping point is. It's about 25% penetration of a new perspective or a new idea. And when you reach that 25%, partly because of the internal dynamics of a complex system, partly because we're such socially minded creatures, people look around and say, oh, the wind has changed, I better tack round to catch it. And then suddenly we see a change of state in society. A classic example is marriage equality, right? Just a few years ago, marriage equality was going to be the end of civilization as we know it. Oh my God, if gay people are allowed to marry, the sky is going to crack asunder and we're all going to die. And now it's like, well, of course, I've always supported marriage equality. And what happened was that gay rights campaigners very successfully expanded those concentric circles of acceptance of that idea until it hit that tipping point of 25%. And then suddenly people didn't want to be left behind. After the war, everyone becomes a member of the resistance. And it was like, sort of, yes, I support gay rights, I support equal marriage. And that's how change happens. It doesn't change from government. As for compensation, as for the money involved, well, the thing is, we're already spending, governments around the world, $500 billion a year on supporting farming. Farm subsidies amount to $500 billion, and almost all that money is perversely spent. It goes disproportionately, by far and away, to the biggest farmers, many of whom aren't farmers at all. They're just absentee landowners. They're dukes and sheikhs and mining barons and hedge fund owners and all the rest of it, but they are harvesting this public money that all of us are paying. It's almost always environmentally damaging. Great deal of it, the majority of those subsidies support the livestock industry. It's just a mad way to spend public money. We could repurpose that money. We could use some of it to help livestock farmers transition out of the industry and into doing something else, like rewilding their land. We should pay for that. If we're paying public money, we should get public goods out of it, not public harms. And we can pay people to do that.
We've got one more question like that. Speaking of ideas coming from the margins, there's a question on the balcony. Yes. So please,
hello,
last question.
Can you hear me?
I can.
This year it's 60 years since the publication of Rachel Carson's Silent Spring. What do you feel that she would feel about what we've done and where we are?
Thank you. Another great question. It is an extraordinary thing, isn't it? That, from the perspective of someone like Rachel Carson, who could see the future, if you were to sort of see the future and look back, she would imagine, surely, that people would act on that knowledge. She would imagine that by the time we got to 2022, 60 years on, we would have put in place all the systems we need to prevent the collapse of the habitable planet. And she would be absolutely horrified to see that we'd done nothing. In fact, for most of that period, there's been international meetings about it. Since 1972, there have been international meetings about it. And we've achieved almost nothing. They didn't intend to achieve anything. If you look at the meeting going on in Egypt at the moment, we've had 26 of these so far, and 25 and a half of them have been a total failure. There was a half success in Paris in 2015, but instead of building on that success, they've just undermined it ever since. And amazingly, out of all those meetings, out of the final declarations of them, only 6 of them even mention fossil fuels. And only 3 of them even mention livestock, the 2 major threats to the global climate. Not even mentioned in most of them. And in no case do they mention extracting fewer fossil fuels or farming fewer livestock. It's all about, maybe we could have a few technological tweaks. And so what we have here, we have the sort of soft facts of government saying, yes, we pledge to have these nationally determined contributions, which will, we hope, on a wing and a prayer, reduce consumption somewhat. And you have the hard fact that they're increasing fossil fuel extraction all the time while doing so. And the soft fact does not negate the hard fact. It's the hard fact which triumphs. And the same applies to our use of land, our pollution of water, the pesticides we're spraying everywhere. All of these things are devastating to Earth systems, and we are not addressing them. And the reason is the power of money in politics. This is the greatest threat to democracy, and it's the greatest threat to life on Earth. We have a straight fight between democracy and plutocracy, and currently plutocracy is winning. And this is why all of these issues are ultimately political. All of these issues ultimately come down to the voice of the people being heard above the voice of money. We can't just leave it to technological change. We can't just leave it to the market, leave it to the invisible hand which will somehow wave this invisible magic wand and make everything all right. We have to mobilize. We have to get together as citizens and ensure that in a so-called democracy, our democratic voice is heard above that of the corporations and above that of the oligarchs. Thank you.
Thank you, George. What a great way to end. It's been a fascinating hour on a topic which couldn't be more important. You've been a great audience. Thank you so much for your engagement and for your excellent questions. Thank you, Tanya, for putting this literary festival on. I'm sorry about the lovely cows and the poetry, George, but it's been a real pleasure. We're walking George now on a tour of various farms in the area. Thank you.